Imagine that a new annual cycle has begun. The Earth rotates slowly, deep in winter, as if quietly holding its breath. Above us, a black ocean of billions of stars, so far away that even the light that reaches us is only a memory. It is not minutes or hours that matter here, but millions of years. Time flows on the scale of eternity, and our calendar is a thin shadow on the face of the cosmic clock. On paper, 2025 is just a date. But in the cosmos, it feels like a door, a small opening in the darkness, behind which something is moving. Something new, something unknown. What secrets await there? What signatures of primeval times will the James Webb Telescope reveal to us? What traces of dark matter will Euclid, Europe's hunter of invisible gravity, find in deep space? And what will the new radio telescope arrays hear when they are placed like ears in the silence, listening for whispers from the early Milky Way? We are on the threshold of a pivotal year, a year in which every new data set could be a shock, in which models are overturned, theories falter, and reality becomes more subtle than we have previously understood. Close your eyes for a moment. Let the sounds of the room fade away. The world becomes quieter, and suddenly the cosmos seems vast, awake, calm, a space that observes us, a space that responds. We are now embarking on a journey not only through space, but through what might come. We dare to look ahead, to where no formulations exist yet, no papers, no headlines. To a place where a folder might appear on a server in July. New spectrum, anomaly. Only a few kilobytes, but with meaning that could shift our view of the universe. What will we see? Perhaps we will finally find traces of the first stars, those colossal, short-lived giants that lit up the early universe like matches in an endless sea of night. They burned hotter than anything that exists today. They died young, and from their ashes arose iron, carbon, calcium, building blocks that we ourselves are made of. Perhaps Webb will not only suggest, but show. Show where the first suns were born. Show how matter became light back then, long before any history. Or maybe 2025 will bring something bigger. Maybe the data will reveal that our cosmic chronology is wrong, that the first galaxies existed too early, too big, too structured, too old for their time. If that happens, the work will start all over again. Cosmology will be rewritten, the history of creation reordered, the Big Bang not discarded, but questioned, with cracks in its foundation. And this is just one path. There could be another. Perhaps dark matter will become visible, not in light, but in behavior. Perhaps in 2025, gravitational maps will show for the first time that invisible mass is not evenly distributed, but flows like a stream, branching like roots, perhaps even pulsing like a heartbeat. Or we discover exoplanets with weather, oceans, magnetic fields. Not life, not yet, but proximity, possibility. But the most significant discoveries rarely come where we look. Often, a single outlier in a curve is enough. A pixel in a deep field image that doesn't belong there. A radio signal that doesn't sound like noise, but like structure. A moment when a scientist pauses in the lab at night, stares at the monitor, and whispers quietly, "That can't be right." And that's where history begins. 2025 is not a year of answers. It is a year of thresholds, a year of wonder. We take a breath now, slowly, deeply, and we move on, into the silence between the stars. We begin at the edge of a year that is still unwritten. 2025 lies before us like a blank star map, lines not yet drawn, constellations not yet named. And yet, if we look closely, we can see contours, projects beginning to mature, missions floating in the dark like sleeping giants. ready to awaken. One of these sleeping eyes is the James Webb Telescope, a golden mirror that looks deeper into the past than any instrument before it. Since its commissioning, Webb has given us images that seem like memories from the cosmos's childhood. 2025 could be the moment when these images become not only beautiful, but disruptive. For while Webb has already provided clues in 2023 and 2024, early galaxies, incomprehensible amounts of dust, star formation at a pace that confounds our textbooks. 2025 could be the year of clarity. Deeper observations, longer exposure times, new filter spectra. Each data set sharpens the focus like a pair of eyes slowly adjusting to the darkness. Imagine the first day in spring 2025, when a team of astrophysicists opens the new series of measurements. A list of numbers, spectra, red shifts. At first, nothing unusual, until a curve appears that doesn't fit. A galaxy of unexpected mass, too old for its light age, too mature for the epoch from which it originates. It wouldn't be the first time Webb has discovered something like this. But 2025 could be the year when outliers become a pattern. At the same time, we turn our attention to Euclid, the seeker in the shadows, the cartographer of the invisible. Its task is not to see, but to sense. Not light, but gravity. If Webb is an eye that sees, then Euclid is a finger that glides tentatively through the universe. It measures how galaxies move, how space bends, how matter acts, even when it remains invisible. 2025 could be the year in which Euclid delivers its first map of dark matter, which is no longer abstract but structured. A network of threads, knots, currents, perhaps chaotic, perhaps symmetrical. And when symmetry appears, the question immediately follows. Why? Who or what shapes it? Is dark matter a medium or a mechanism? We imagine scientists sitting in the control room as data comes in live. An image slowly emerges on the screen, not made of colors, but of forces. A pattern emerges that resembles neural tissue. Galaxies as synaptic points, space-time as connecting fibers, the cosmos like a brain thinking across billions of years. A comparison that is poetic, but not impossible. While Euclid maps and Webb observes, radio telescopes listen. SKA, the Square Kilometer Array, continues to expand. Its baseline grows, its sensitivity increases. 2025 could be the first year in which it receives signals that are deeper than any noise before. Cold hydrogen lines from the cosmic dawn, echoes of a time when the first stars were not yet burning. It would be the quiet birth of light. In the same year, missions to exoplanets will expand their data sets. TESS continues to catalog. Plato is being prepared. And wherever shadows dance around stars, speculation arises. Atmospheres of oxygen and methane, a combination that suggests life. Maybe an ocean, maybe clouds, maybe nothing. But hope is enough to spark questions. One can really imagine a single team, somewhere between California and Heidelberg, sitting late at night in the university, coffee and monitors flickering. A light curve dances, showing a dip that no one expected. A planet smaller than Earth, but in the habitable zone. Not hot, not dead, just quiet. Ready for further measurements. This is where the excitement begins. No one knows about it yet. The world is still silent, but a few people have seen these numbers, and their faces glow with the expression that every discovery carries. The moment when knowledge tips over. There is only a breath's difference between not knowing and knowing. 2025 could be a year of such breaths. We can already sense something growing in the silence. Data that is still raw, lights that first need to be deciphered. A universe that no longer just gives us answers, but counter-questions. Every discovery a mirror, in which we see ourselves anew. Because when we understand how stars were formed, we also understand where our atoms come from. When we see dark matter, we see the structures in which we exist. When we find new worlds, we may find ourselves reflected in alien oceans. It is a beginning of the year full of expectation. No fireworks, no noise, but a silent countdown in observatories, data centers, control rooms. Every researcher a chronicler of the cosmos. Every server a bridge to the past. And somewhere deep in space, a photon is traveling right now, 13 billion years old. Long before it reaches Earth, neither we, nor our cities, nor our calendar exist. But this light is on its way, unstoppable, purposeful, and in 2025, it may hit a golden mirror and tell its story. Looking into the future of astronomy in 2025 means not only anticipation, but preparation. New observatories are sprouting like seeds in the ground, still inconspicuous, but full of potential. Some are already active, others are just awakening. But one thing is certain. 2025 will be a year in which tools become sharper and questions become bigger. Let's start with Nancy Grace Roman, the telescope already being called the wide-angle successor to Hubble. Not because of its depth, but because of its breadth. Roman will not look into the distance in a selective manner like Webb, but will capture entire regions of the sky, as if looking through an open door rather than a keyhole. Millions of galaxies in a single scan, each one a story, each point of light an archive. Imagine Roman creating the first survey maps in 2025. Not one image, but thousands. Not one database, but an ocean. In this ocean, we could find patterns we never expected. Galaxy filaments that are wider than we thought. Empty spaces in space that appear larger than models allow. Perhaps we will discover regions where matter is missing, or surprisingly concentrated. Each such outlier would be a piece of the puzzle that describes dark energy, a force that pulls the universe apart and remains a mystery to this day. Dark energy is the great specter of modern cosmology, invisible, unmeasurable in the classical sense, but noticeable in the expansion of the universe. Roman could reveal its fingerprints in 2025. Tiny deviations in structure, subtle shifts in redshift. If these deviations occur consistently, there is a chance that we will finally be able to grasp one of the greatest cosmic parameters, not just as a concept, but as a measurable reality. But it's not just large telescopes that will be speaking in 2025. Small missions could also make themselves heard. Mars remains an active scene. Rovers continue to send sample analyses, helicopters fly, and ground drilling goes deeper. 2025 could be the year in which the first return transport of rock samples to Earth is prepared. A project that would be technically enormous, but scientifically priceless. 1 gram of Martian soil could carry more answers than 1,000 photos. Organic trace chemistry, microfossils, mineral fingerprints of ancient oceans. Imagine what it would mean if an electron microscope found a fossil on Earth. Not certain, not confirmed, but doubtful enough to leave the world breathless. Meanwhile, attention is also turning far beyond the solar system. Missions to Jupiter's moons such as Europa, Ganymede, and Enceladus, places where oceans could be boiling beneath ice sheets. 2025 could be a year of preparation, a year of defining goals. When initial flybys deliver new data, we could see thermal activity, plumes of water vapor, perhaps even more complex molecules. Where there is water, we search for life. And where complex chemistry exists, the question of biology arises almost automatically. At the same time, the search for technosignatures will continue. Radio telescopes scan narrow frequency bands, Laser detectors search for pulses that are too precise to be random, artificial signals that cannot originate from natural phenomena. The probability remains low, but a single hit would rewrite the entire history of humanity. 2025 may not bring contact, but it could be the year when the signal appears that is only recognized as artificial years later. This is how every revolution begins, inconspicuously. And then there is quantum astronomy, a new field, young and ambitious. Photon entanglement over astronomical distances. Experiments in which light is not only measured but understood as a carrier of information. If, in 2025, the first measurements show that quantum coherence survives longer than expected, it could mean that the universe is more communicative than we thought. Perhaps photons store stories not only in their spectrum, but also in their state. Perhaps the light that reaches us is not only old, but consciously structured. We are now opening the next window into the future, a quiet step deeper into the year 2025, where data is no longer just a promise, but is taking shape. The cosmos remains infinite, but our view of it is becoming sharper, as if someone had polished the glass of a telescope. What was only a hypothesis yesterday could be a measured value tomorrow. One of the most exciting fields that will be in motion in 2025 is the early history of the universe. Webb has opened the door through which we can see what existed just seconds after the Big Bang. But 2025 could be the moment when this door is not only open, but widening. We are talking about the ionization epoch, the first formation of heavy elements, structures that formed while space-time was still soft, malleable like wet clay. Imagine an image, a deep field deeper than anything before. In this depth, you find light that should not shine, stars that should not exist, galaxies already ordered, even though there was hardly enough time for them to find their shape. The question that then arises is almost poetic. Did the universe learn faster than we think? Was its childhood more mature than our models allow? If 2025 is the year when these anomalies become more numerous, it could be a turning point, a moment when we have to admit that our mathematical constructs are not big enough to comprehend the heavens. Perhaps cosmology needs more than formulas. Perhaps it needs intuition. At the same time, we are looking deeper into the nature of gravity. We have understood it for 100 years, or at least we think we have. But dark energy, dark matter, and early galaxies are increasingly asking us, what if gravity works differently beyond a certain scale? What if space-time is more elastic, more flexible, perhaps even quantized? New detectors in 2025 will detect gravitational waves even more sensitively. Not only mergers of black holes, but perhaps also signals from much earlier times. From the phase transition of the early cosmos. Small tremors in the fabric of space-time, like the memory of growing pains. If these signals are found, they would be like an echo from the time before stars existed. At the same time, helioscience continues to evolve. The Sun, our closest star and yet a mystery. Its magnetic cycles, its spots, its flares. In 2025, new solar observatories will measure its activity, perhaps more precisely than ever before. They will map heat gradients, observe plasma flow, analyze turbulence. Could it be that we will discover patterns that allow us to predict solar storms? Because a single large CME eruption could set our technology back years. And yet, we have only been observing this star for the blink of an eye in cosmic time. It is conceivable that by 2025, we will understand why the Sun pulses in regular cycles, why it has periods of calm and periods of chaos. As this knowledge grows, so does our security. Not in the astronomical sense, but in the human sense. Meanwhile, our gaze extends beyond the stars to worlds that may be breathing. Exoplanet research in 2025 will no longer mean just finding, but analyzing. Atmospheres are broken down into their components. Spectral lines reveal whether water is evaporating or condensing, whether methane is photolytically decomposing or being newly formed. If one of these signals appears in combination, oxygen plus methane plus temperature in the habitability window, then that would not be proof of life, but a call for attention. Imagine a single dataset appearing in August 2025. An exoplanet, barely larger than Earth. Transit perfectly measured, atmosphere clearly detected. Traces in this atmosphere, not much, but enough. A pattern that keeps researchers awake while the rest of the world sleeps. Such a moment would be like a pulse of humanity. But 2025 could also be a year of surprises, when the unexpected happens. Perhaps we will discover something that does not appear in any theories, a form of matter, a cosmic object that cannot be categorized, a star without a spectrum, a planet without mass, a black hole with rotation that doesn't follow any equation. The history of astronomy shows that every century reveals at least one discovery that no one was looking for. And when that moment comes in 2025, it will begin quietly, in data, not headlines. Just as the cosmos always begins, silently. You can almost hear the year breathing. Instruments in operation, missions in planning, data streams growing like roots underground. We are still early in the course of this year, but the pace is picking up slightly, like a wave gathering before it breaks. We continue to move through 2025, deeper, more focused, as if the cosmos itself were coming a little closer to us. In the first few months, there are still individual data points that appear like drops on a mirror. But drops become lines. Lines become patterns. And suddenly structure emerges. That is the moment when science begins to not only collect, but to understand. One area that could see particular growth in 2025 is the analysis of interstellar chemistry. We are talking about molecular clouds, cold gas that glows like a veil of mist in the starlight. But behind this poetic image lies a powerful question. How does complexity arise in the universe? How do simple atoms, hydrogen, helium, transform into amino acids, sugar molecules, the building blocks of life? We already know that such molecules exist in space. But 2025 could be the year when we not only register their presence, but understand their formation. New spectrographs, sharper than their predecessors, break down light into finer lines. What used to be a single measuring point will now become hundreds. Where we once saw only traces of methanol, we may in future be able to identify entire reaction chains. Perhaps we will discover intermediate stages, molecules that only exist when life or precursors of life arise. It would then no longer be just a question of whether the cosmos knows chemistry, but whether it is preparing for biology. And while chemical clouds are being studied, observatories are also focusing on magnetic fields. For a long time, they were considered a marginal topic, a side effect, a detail. But in recent years, it has become clear that magnetic fields shape stars. They direct matter, bundle gas flows, and smooth out turbulence. When the first complete magnetic maps of several star-forming regions become available in 2025, this could change our understanding of how stars are born, not chaotically, but directed, structured, almost organized. Imagine recognizing how magnetic fields pull and hold matter like invisible hands. Their lines form networks in which dust collects, becomes denser, and begins to collapse. Stars would then be not only thermodynamic events, but magnetic constructions of space itself. The observation of black holes will also continue to grow in 2025. The Event Horizon Telescope is planning new campaigns, finer resolution, shorter integration times. Perhaps a second look at Sagittarius A will be possible, sharper than the first. Perhaps an image will emerge that shows not only a shadow, but rays, dynamics, accretion motion like flowing fire. Such an image would be more than art. It would be data physics. At the same time, rotation rates could be measured, jets mapped, magnetic structures tracked. When patterns repeat, theory emerges, and theory leads to understanding. But it is not only large objects that fascinate, empty space itself speaks. Quantum fluctuations in a vacuum, virtual particle pairs that arise and disappear. In 2025, experiments could provide the first indications that space is not empty, but active and full of energy. Perhaps we will measure Casimir effects on a cosmic scale, no longer just in the laboratory, but between galaxies, where gravity is weak and space is sensitive. What if vacuum energy is not constant? What if it pulsates? This year, a paper could be published, inconspicuous, 30 pages, PDF, without much media coverage. It contains a hint that the fundamental constant of dark energy drifts minimally, barely measurable, but consistent in 3 measurement series. At first, the scientific community smiles mildly, but 3 months later, a second analysis confirms it. And slowly, the suspicion gains weight. Not loud, not explosive, but quiet, like all truth in the cosmos. We imagine a young physicist sitting alone in a lab somewhere at night. A monitor, a diagram, a peak that refuses to disappear. He rubs his eyes, zooms in, checks the calibration. But the peak remains. It is small, but it exists. At this moment, history is made not in words, but in heartbeats. At the same time, another field is growing. Artificial intelligence in astronomy. By 2025, models will not only sort data, but also generate hypotheses. AI systems will search through millions of spectra, finding patterns that the human eye would never notice. Perhaps in 2025, a machine will discover the first evidence of a previously unknown class of particles. Not through understanding, but by recognizing structure in the noise. The researcher reads just one line in a report. Anomaly Group 19b. And that's where the change begins. We now step deeper into the year 2025, as if crossing a threshold behind which the future is already quietly breathing. The first 4 chapters were like arrival and setup, an awakening of the instruments, a murmur of data. But from part 5 onwards, the year no longer just whispers, but speaks, not loudly, not dramatically, but steadily, inexorably, like light that has traveled for billions of years and now touches the detector. Amidst these growing insights, one topic is becoming increasingly central: the question of the first stars. Population 3, a name that is almost legendary. Stars without metals, without heavy elements, pure, like the universe itself in its youth. Decades of research have yielded only indirect evidence, modeled spectra, presumed signatures. But 2025 could be the year when their existence is not only suspected, but observed. Imagine the moment. A deep field, even deeper than the previous record. A tiny trace of light, barely examined, and yet it bears the pattern that has been sought for so long. No iron, no magnesium, no metals. Only hydrogen, helium, and perhaps lithium, the earliest building blocks. If this light is clearly confirmed, it would be like a glimpse into cosmic childhood, into a chapter that has been only theory until now. It would not be a loud triumph, but a quiet one. As the search for the first stars progresses, another field is growing equally: the cartography of large-scale cosmic structures. Euclid is delivering data in streams. Millions of galaxies interconnected like synaptic stars in an infinite brain. In 2025, scientists could begin to recognize patterns in it that go deeper than gravity alone. Perhaps preferred directions will emerge. Perhaps there are regions where dark matter flows more densely, like watercourses in the mountains of space-time. If such patterns are found, it would be more than statistics. It would be an indication that the universe is not expanding in a purely chaotic manner, but in a structured way. Not randomly, but dynamically. The question, then, is no longer whether we can understand dark matter, but how it thinks, if one may venture to use that word metaphorically. In parallel, Webb could begin collecting new spectra from dust disks around young stars in 2025. Planets form in these disks, not in years or centuries, but in millions. But Webb could see signatures in these spectra that are rare and valuable. Prebiotic molecules, complex organic chains, perhaps even evidence of self-organization. If the emergence of life is not an exception, but a consequence of cosmic chemistry, then we would not be alone, just a variation. The idea is not bold, but calm, a possibility that grows like a quiet echo. Even in the solar system itself, 2025 could be a year of discovery. Missions to Titan, Europa, and Enceladus will deliver high-resolution data on ice, tides, and cryovolcanoes. Scientists have suspected for years that oceans exist beneath the crusts of these moons. Warm, salty, turbulent, perhaps crisscrossed by hydrothermal vents. If initial measurements show that organic molecules are more common there than in meteorites, then this would be a window through which biology becomes conceivable. Imagine a paper in the fall of 2025. Laconic, scientific, without pathos. But one sentence in it breaks through like light through fog. We have registered evidence of long-chain organic structures in the subglacial ocean. Not life, but proximity. At the same time, a new tool is emerging on Earth. AI-supported analysis of anomalies. It is not humans who find the patterns, but algorithms. They comb through terabytes of raw data, searching for deviations that are too small to be noticed by the human eye. 2025 could be the first year in which an algorithm recognizes a cosmic signature that is ahead of human interpretation. Perhaps a machine will find evidence of an object that does not appear in any model. A star without nuclear fusion, a galaxy without a visible halo pattern, a planet with unimaginable albedo. The researcher reads the report. Just one line. Cluster ID, 7A, unclassifiable. And in that moment, he senses that the future has begun. As data grows, so does philosophy. Because every spectrum, every image, every curve forces us to ask questions that are bigger than physics. What does it mean to see the first light? What does it mean to recognize structures in the dark? If life is not rare, then who are we? 2025 is not a year of answers. It is a year of realizing that answers might exist. We now stand at the edge of this thought, as if at an abyss that is not threatening, but beautiful. A cosmic horizon into which we must continue quietly, step by step. We are now entering the middle of our year 2025. The first few months were preparation, the structures were built, the measurement series began. But now, in the middle of this year, the picture is shifting. The cosmos is no longer just allowing itself to be observed. It is beginning to look back. And this feeling, this almost imperceptible shift, makes 2025 a year that sounds different from the years before. The data streams are becoming denser. Webb, Euclid, Roman, 3 eyes on 3 levels of reality. Webb looks into the past, Roman into the distance, Euclid into the invisible. Together, they form a triangle of knowledge. an instrument that not only depicts the universe, but also deciphers it. And this is where the excitement begins. Because sometimes three perspectives do not tell the same story. Imagine, in the summer of 2025, teams published two papers simultaneously. Webb shows early galaxies that are too large for their time. Euclid measures dark matter structures that could perhaps explain this growth. At the same time, Roman maps the distribution of galaxies with a breadth that allows for statistical precision we have never had before. But then the unexpected happens. The data doesn't match. Slightly shifted, minimally offset, but consistent. It seems as if a parameter is wrong, as if something is missing in the foundation. This is where the part of the year begins that makes science and philosophy inseparable. Perhaps light is not as constant as we believe. Perhaps space does not expand at the same rate everywhere. Perhaps time itself is not a universal flow, but a field that can be bent. 2025 could be the year when theorists become bolder, when they begin to write models that not only explain the data, but allow for the unthinkable. Variable C, modified gravity, time as an emergent property, not as an axis. As theory grows, observation begins to reach its limits. Integration times become longer, data volumes heavier. AI takes over preliminary analyses. Humans only intervene where machines are at a loss. 2025 will be the year in which science works differently. Not faster, but deeper. And in this depth lies the surprise. A new method of exoplanet spectroscopy emerges. Instead of observing transits, reflection is measured. Dayside, nightside, weather cells. A planet is no longer seen as a point, but as a changing light pattern. If this method is successfully applied in 2025, we could measure wind speeds on an alien world for the first time. Cloud formations, seasons. And if seasons exist, stability exists. And where there is stability, biology can take root. Meanwhile, another project is investigating interstellar solids, dust that is older than our sun. Meteorite analyses in 2025 could show that some grains were formed before our galaxy was fully formed. If carbon crystals are found whose isotopic signature does not match our star population, it means that life had building blocks long before stars like the sun were born. This idea changes everything, not because it is loud, but because it is silent. If the building blocks of life are older than our world, then biology was never an exception. It was a consequence, almost inevitable. But 2025 also holds the possibility of wonder on the smallest scale, quantized space-time. Experiments in observatories could show that photons do not travel continuously, but in discrete pulses. A cosmic grid, finer than any atom. If this grid is confirmed, a new era of physics will begin. Not classical, not relativistic, quantum cosmological. Imagine a single diagram, barely visible, shows slight deviations in the transit times of high gamma rays. 3 observatories confirm. 5 weeks later, a paper appears. Evidence of discrete structures in the space-time metric. Cautiously worded, but powerful. This would not be a breakthrough like fireworks. It would be a breakthrough like a breath of air. We are now moving into the second half of 2025. The first few months were speculation, the middle was consolidation. But from this point on, the year begins to speak. Not in whispers, but in clear lines, astonishing patterns, distinct numbers. It is the phase in which intuition can become certainty. The data is now so abundant that no human team can read it alone. Supercomputers run continuously. Neural models examine signal noise like archaeologists searching for bone fragments in the sand. And suddenly, without warning, without drama, traces are found. Small but consistent. In July 2025, a recurring signature appears in Webb's datasets, a spectral ratio in the UV range that is identical in several early galaxies. No noise, no miscalibration, something structural. At first, the scientific community remained silent, because such a discovery requires caution. But 3 months later, independent teams confirm the same signature. They initially give it a neutral name, Type L emission. Type L, the first fingerprint of population 3? Or a process we don't yet understand? Imagine the scene. A conference hall, subdued lighting, projections in the dark. A scientist steps up to the podium and shows a diagram. Lines, clear, clean, repeated in 4 datasets. The hall falls silent. And in this silence lies the weight of centuries of research. It is not a moment of jubilation. It is a moment of bated breath. At the same time, our understanding of gravitational waves is growing. New detectors work together, synchronized across continents. They no longer detect only black hole mergers, but finer, quieter signals, waves from the early cosmic phase. Some researchers are already talking about the texture of space-time, as if the universe were not just a fabric, but a fabric with a pattern that could be read. If 2025 provides the first evidence that gravitational waves are not randomly distributed, but show slight harmonies, then we would be witnessing physics on a level deeper than relativity. Perhaps there is information there. Perhaps memory. While the theory matures, decisive events are also taking place in the solar system. Mars is sending new soil profiles, crystalline structures unexpectedly symmetrical. Some researchers suspect geological processes. Others see possible biomorphisms. No evidence, but enough to briefly alarm the world press. But the truly extraordinary is happening quietly. Measuring instruments on Europa, Jupiter's ice-covered moon, are registering unusual heat signatures. Plumes active ascents of warm liquid from dark depths. For the first time, a model is being created in which ocean currents under the ice can be mapped. Some zones show temperature gradients that indicate energy-driven movement, a system that is dynamic, not static. If there is movement, there is exchange. If there is exchange, there is chemistry. And chemistry is always the beginning of stories. It is conceivable that in the fall of 2025, a paper will be published with the unassuming title, Thermal Variability in Subsurface Oceans of European Icy Moons. But the world will remember only one sentence from it, one that is quiet but powerful. The observed gradients are consistent with local chemical energy production. No life, but the possibility of its ignition. Meanwhile, another project is moving forward. The search for technosignatures. Not life, civilization. In 2025, radio telescopes will work more closely, more precisely, more focused. They will not only scan broadband signals, but modulated patterns, rhythmic pulses, sequences that are too structured to be natural. Perhaps an observatory will detect a signal with non-Gaussian periodicity. No proof, but cause for attention. A pattern that doesn't sound like pulsar noise, not like mass emission, not like interference. A signal that seems different, not loud, not clear, but different. Researchers in the SETI community will stay awake at night. Some will express quiet doubts, others tentative hope. And between the two lies the zone where the future is born, cautiously, without haste, but inevitably. Meanwhile, new instruments are emerging on Earth, spectrographs that measure not only light, but polarization. If 2025 shows that polarized starlight is refracted abnormally in certain areas, this could provide clues to substructures in the interstellar medium. Perhaps magnetic filaments, perhaps dust streams, perhaps unknown particles. Each possibility requires a new theory. Imagine that in November 2025, a diagram appears, inconspicuous, clear, 2 lines, one deviating, only 0.3%, but stable, repeated, confirmed. Such a fragment could be the basis for an entire generation of research. We are now entering the moment of the year when assumptions become suspicions, and suspicions become quiet tremors. Part 8 is the zone between knowledge and intuition, between analysis and revelation. This is where the universe begins, not only to reveal itself, but also to confuse us. Summer turns to fall. The mountains of data are now gigantic, and science is at a point where every new line in a measurement series could tip the world, not through spectacle, but through consistency. Several teams around the world are now reporting the same observation. Early galaxies are not only more numerous than thought, they are structured. Too structured. They show rotation curves more reminiscent of mature systems than cosmic infants. One researcher writes in a paper, "It seems as if the universe practiced less than expected and remembered more." A sentence, delicately worded, but enormous in meaning. While this discussion is ongoing, further results from Euclid are emerging. The mapping of dark matter is becoming more refined, and suddenly gaps are appearing. Regions in space where gravity behaves differently than models predict. Not weaker, not stronger, just phase-shifted, as if invisible mass were not flowing evenly, but pulsating. Some begin to ask, does dark matter have rhythm? If so, who sets the beat? At the same time, another instrument surprises us. In September 2025, Roman delivers the first large-scale maps of cosmic voids. But something is puzzling. Some voids appear symmetrical. Not random, not chaotic. Symmetry is rarely a product of chance. Symmetry is reminiscent of law, of order, and order requires a cause. At this point, the scientific world gently splits into two schools of thought. Some say, we are on the verge of understanding early cosmology. Others whisper, perhaps we have been looking for the wrong quantity. As debates grow, new observations from radio data appear in October. The SKA receives signals, not artificial, not technological, but strangely coherent. Hydrogen lines from the ionization phase show wave-like variations in intensity. Regularities, sequences, no ET, no code, but patterns. One scientist says in an interview, it's as if the early cosmos itself was vibrating. Another, perhaps the universe was less of an explosion and more of a resonance. This idea begins to spread. First among experts, then among the wider physics community. If resonance exists, it could carry information. And if information exists, then from the very beginning, the cosmos was not just matter, but process. A universe that not only comes into being, but remembers. At the same time, exoplanet data is becoming increasingly refined. Webb registers traces of oxygen combined with methane in the transit spectra of 2 planets. No confirmation, no press coverage, but behind closed doors, people are whispering. The pattern is not yet stable, but it is there. Researchers are beginning to extend measurement cycles, recalibrate instruments, and eliminate sources of error. Because when oxygen and methane coexist, there are only 2 possibilities: active geology or active biology. And biology would be the bigger story. As the tension mounts, another paper appears, unassuming in title, but with a sentence that cuts through the scientific world like a quiet electric current. The measured structure of cosmic voids is compatible with periodic energy distribution in the early universe. Periodic, not random, not chaotic, like a heartbeat. One begins to speak metaphorically, but metaphors are sometimes premonitions. Perhaps galaxies were not products of chance, but of rhythm. Perhaps order arose not despite chaos, but through chaos. Resonance as the origin. And then the first small hammer falls. Identical deviations in polarization patterns are discovered in 3 independent data sets. Minimal, but exactly the same. Not explainable by instruments. Not by error. The scientific community holds its breath. There are no headlines yet. No revolution yet. But the door is open. It happens in November 2025. A team publishes an analysis that makes people sit up and take notice. The earliest galaxies not only show unexpectedly high mass, but synchronous structure formation. Several systems, far apart from each other, develop similar star populations in similar times. Not identical, but harmonious. Harmony is no coincidence. At the same time, new measurements of polarization deviations appear, which already gave a faint hint in Part 8. Now there are no longer just 3 observations, but 8. 8 independent recordings, 8 correlations, all in a similar angular range. Statistical noise? Hardly. Instrument error? Out of the question. What remains is a hypothesis, cautiously formulated, but no longer avoidable. The cosmos could be structured, not only in space, but also in time. Some researchers are beginning to use a word that was previously unthinkable: periodicity. Not expanding randomness, but oscillation. Not chaotic birth, but pulse. If galaxies react like resonating bodies, then the universe would not only be space, but process. And processes carry information. As this realization begins to cast its shadow, something else is happening in parallel. Radio observatories report a signal. Not artificial, not technological, but orderly. A pattern in hydrogen lines that recurs. For 3 weeks. Every 7th day, periodically, constantly. Too weak to suggest extraterrestrial intelligence, too precise to be coincidence. The scientific community remains calm, out of caution. But something is growing beneath the surface, like an underground river. Skepticism does not crumble, it becomes mindful. Roman provides more void data. Again, symmetries, again, structures. Some researchers compare them to interference patterns, others to sound images. A metaphysical seeming thought begins to form. Perhaps the universe is not an object. Perhaps it is a sound, not a sound that ears can hear. A cosmic rhythm embedded in the structure of space-time itself. Meanwhile, Webb brings another piece of the puzzle, one that finally breaks the tension. A deep field image shows galaxy populations that are too close together in age and metallicity to have arisen purely statistically. It is as if several regions of the early universe received the same initial impulse. Not simultaneously, but in unison. At this moment, Part 9 becomes the tipping point. A paper appears, 54 pages, double-checked, coolly written. No spectacle, no sensational words. Just one conclusion, soberly formulated like a knife. The observed parameters are consistent with the universal rhythmic initial state. Rhythmic, initial. That means not coincidence, not random, a beginning with a pulse. It doesn't have to be a heartbeat, a sound, or a will. But it is order, an order older than any atom. And as this realization flows through the scientific fabric like electricity through metal, the world reacts. Some remain skeptical, cautious, critical, vigilant. Others are already talking about a paradigm shift. But reality is silent and deep. It does not call out. It flows. We are now at the beginning of the third act. The threshold has been crossed. Everything that was previously conjecture is now taking shape. No longer just a hint, but form. This is the part where the universe is no longer being observed, but responds. December 2025 begins. Snow falls somewhere on Earth, and at the same time, light that has been traveling for billions of years falls into the mirrors of the Webb Telescope. It reaches us, quiet and unexcited, as always. But this time, it is seen differently. Because now we know what we are looking for. The rhythmic signatures, the polarization patterns, the periodic voids, they were puzzle pieces, fragments of an image that doesn't yet have a name. But in part 10, these fragments begin to come together. A pattern forms slowly, like a nebula condensing until light is created. It begins with a publication from 3 independent observatories, a joint evaluation, months in preparation, thousands of GPU hours calculated. The result seems inconspicuous at first, a graph, a histogram. But the axes tell a story. You can see a vibration, not loud, not big, but stable. A wave in the cosmic background, not a gravitational wave, not an EM line. Something deeper, something that pulses in the foundation of space-time. One researcher puts it soberly. There is evidence of a coherent phase in the early universe. Phase, not coincidence, not chaos. If a phase exists, structure exists. If structure exists, something that creates it exists. At this point, the discussion becomes existential rather than academic. What is a universe that carries rhythm? What does it mean to have a beginning that doesn't simply explode, but vibrates? Some speak of field resonance, others of supercosmic symmetry. A young group dares to use a bold-sounding word, memory. Not in the biological sense, not as spirit, as a physical property, as the persistence of order over time. And while this hypothesis is still being tentatively formulated, the second hammer of the act falls. Webb delivers an image deeper than any before. A deep field that shows not only galaxies, but patterns in their distribution. Not regular, not perfect, but recurring. In several regions of the sky, clusters appear at similar distances. Far too similar for coincidence. One team describes it this way. The distances between certain clusters follow a sequence that cannot be explained stochastically. Sequence. Distance. Recurrence. The vocabulary changes. We used to talk about matter, energy, expansion. Now we talk about intervals, cycles, patterns. The scientific community is not panicking. It is becoming silent. And silence is always the sign before history tips. Resonance in background radiation. Resonance in structures. Resonance in the void pattern. 3 independent fields. 1 phenomenon. What was previously only a hypothesis is now becoming a possible model, and this model raises the question that can no longer be avoided. Does the universe have an origin with rhythm? Not like music, not like a heartbeat, but like an initial condition that oscillated before space and matter formed. A vibration that needs no melody, only recurrence. And if the beginning was recurring, then the future could be too. Not cyclical like myth, physically periodic. Some researchers cautiously speak of metrically periodic expansion. Others put it more simply. Perhaps the Big Bang was not a one-time event. And that is where the first real upheaval begins. Not because the evidence is conclusive, but because doubt is finally becoming fruitful. A universe that pulsates. A space that does not expand statically, but carries waves. A reality that does not fall silent, but vibrates. In this atmosphere, a young cosmologist asks a question in an interview that goes viral, quietly like a drop in water. If the universe carries patterns, what does it resemble? No answer, only echo. An image emerges slowly, as if drawn from darkness. Webb observes the region where the population 3 candidates were found once again. this time in an even deeper spectrum. And there, in light older than any generation of stars, lines are found that do not appear to be random, not an absolute repetition, but a sequence. A pattern too complex to be noise, too subtle to seem artificial, as if the early universe itself bore an imprint. Not language, not code, just time-bound order. At the same time, measurements in the 21 cm range are intensifying. The rhythm that first became apparent in Part 10 is growing stronger, not in volume, but in confirmation. 8 independent instruments report the same modulation. Small, regular, persistent, finer than any gravitational signal, older than any galaxy. Data is checked, models are dismantled, hypotheses are reborn. And suddenly, a sentence appears, published soberly in the journal, but heavy as cosmic lead. If this periodicity is fundamental, then time is not continuous, but quantized. Time in steps, time in pulses, time as a grid. This idea is bigger than space, bigger than gravity or dark matter. Because if time does not flow but pulses, then everything that exists is a sequence of movements. Every atom, every star, every thought. Events on a grid, not coincidence. Sequence. And then comes the second blow of this chapter. A new analysis by Euclid shows not only structures in dark matter, but phase shifts. Areas where the density distribution appears to be minimally delayed, as if the universe were not aging everywhere at the same time. Not much, just fragments of percentages, but consistent. A team of researchers writes, "If our model is correct, it is not only space that is expanding, but rhythm." These words have a seismic effect on the foundations of our worldview. It is not space that is expanding uniformly, rhythm is expanding with it. The universe has not only become larger, its pace has slowed, like living systems whose pulse slows with growth. And at this moment, thoughts arise that were previously taboo. Was the Big Bang an impulse? Was it the first beat of a cosmic heart? Or the first note of a sequence that is still ongoing? No religion, no metaphysics, pure physics, but with poetic sharpness. As these ideas grow, another observation is added. Exoplanets with oxygen-methane combinations show slight temporal variations. Not stable, but resonant. As if even atmospheric chemistry were reacting in time with a larger order. Researchers are cautious. Correlation is not causation. But some ideas don't need to be proven to breathe. An interdisciplinary group proposes a model that sounds disturbingly simple. If the universe was created in pulses, each galaxy could be a phase section, each star population a beat, each extinction epoch an interval, not because there is intention, because there is structure, and structure carries direction. In this chapter, a new term begins to enter the discourse. Quietly, cautiously, but inevitably. Cosmic memory. Not memory in the sense of consciousness. Memory as the persistence of patterns across space-time. The universe does not forget how it came into being. It repeats it in faint, distant echoes. And we, a late result of this pattern, are beginning to hear it. The first major breakthrough comes from a consortium combining data from Webb, Euclid, and weeks of calculations. Billions of data points. A pattern emerges, faint but unmistakable. The background radiation shows frequency bands that cannot be explained stochastically. They are periodic, and not just once, but 3 times harmonically, like the overtone structures of a sound. One researcher puts it soberly. If these harmonies are real, the universe carries more than history. It carries structure. It is a sentence as quiet as falling snow, but as deep as the ocean. But then comes the second step, the one that takes your breath away. A team reanalyzes cosmic expansion, not classically, not linearly, not based on inflation, but rhythmically. They find that fluctuations in the large-scale void pattern correlate with the polarizations and with the 21-centimeter resonance. Triply confirmed, independent, reproducible. The first model of a universe with a beat pattern emerges. Not sound, not a heartbeat. A physical oscillator of space-time. People begin to describe expansion as a vibration. Phase 1, initiation. Phase 2, expansion. Phase 3, feedback. Phase 4, renewed expansion, not cyclical, iterative. A universe that does not circle, but grows like breath. Some scientists are saying it out loud for the first time. Perhaps the Big Bang was not the beginning, but the first impulse in a sequence. And as this idea permeates the scientific community like a slow current, another result emerges. Exoplanets with oxygen-methane atmospheres show synchronous deviations in their spectrums, all in similar phase windows. Not strong, not conclusive, but parallel to cosmic harmony. A synchronous beat between the macrocosm and the microcosm. No coincidence seems like coincidence anymore. Planetary systems could not only arise, but arise in unison. Chemistry could not only react, but react in rhythm. That doesn't mean the universe is alive, but it does mean that it is structured like something that can remember. But here comes the part that turns everything upside down. A group of physicists is proposing the most radical hypothesis of the year. One that is not religious, not mystical, but empirically conceived. If the universe has patterns, it could store information, not consciously, not purposefully, but as a physical property, like a crystal that remembers vibrations, like a neural network that stores signals, like an ocean that carries wave patterns. This hypothesis is cautiously called memory topology. Cosmic memory not as spirit, but as structure. And while the world remains silent about this idea, another finding emerges. Galaxy clusters show anomalies that appear like whispers of a lost signal. Tiny density shifts that are in tune with background harmonies. It is as if billions of light years apart, they carry the same wobbly patterns, like a shared echo of their origin. A scientist says at a conference, perhaps the universe has no beginning. Perhaps it has a motive. A motive. No will, no intention, just a recurring phrase in the structure of reality. And in that moment, fear is born, not of darkness, but of meaning. One understands without saying it. The universe does not only have a past, it has a signature. We have reached the end. Not the end of the cosmos, just the end of the path that this year has opened up. Part 13 is not a climax. It is an exhalation, a slow closing of the hand that held something invisible. 2025 began with questions. It ends with a feeling, not certainty, not an answer. Something deeper, a quiet knowledge. The last data of the year arrives while winter reigns somewhere on Earth. Observatories switch to maintenance mode. Mission teams write their final reports. But it is not the instruments that make this chapter significant. It is the view they have made possible. The cosmos has not become smaller through knowledge. It has come closer. The rhythmic signatures, the harmonies in the background, the periodic voids, they have not disappeared. They are clearer, not fully explained, but no longer ignorable. The idea of a universe with rhythm is no longer bold. It is an object, a field of research, a possibility. And as the world prepares for a new year, somewhere a student is working in a quiet laboratory, laptop open, head in his hands. A plot flickers before him. Slight fluctuation in polarization data, recurring, confirmed. Not a breakthrough on its own, but every breakthrough begins like this. What 2025 has brought is not proof. It is direction. Science now speaks of space-time not as a surface, but as a fabric. Of time not as a flow, but as a sequence of steps. Of existence not as a state, but as movement across a grid larger than stars and smaller than light. We are beginning to understand that order may not be the exception, but the fundamental condition. Perhaps the universe is not a mystery, but a song too big for a single ear. Perhaps we are not a coincidence, but resonating bodies in this sound. Not the center. Part. A galaxy pulsates in the cold vacuum, like a heart in slow motion. A photon travels billions of years only to encounter a piece of silicon. And somewhere, a human being sits, breathes, thinks, questions, and is itself part of the same pattern. That is the quiet miracle of this year. Not that we found the answers, but that we finally heard that questions are rhythmic. Sometimes the universe does not need to be spoken. It is enough to listen to it. We are not ending the year with a full stop, but with a comma, because everything that is understood now is only the beginning. Science never rests. Neither does the cosmos. Rhythm never does. We leave 2025 like a ship leaving port, not because the water has run out, but because the sea is finally beginning, and the sky above is no longer silent. It sounds. That is the legacy of this year. Not evidence, not theories, but the awareness that reality has structure. Perhaps vibration, perhaps memory, perhaps something that does not yet have a name. But it is there, and those who listen will hear it. This is how our journey ends, not with a full stop, with an echo. A universe continues to breathe, and we breathe with it.